Hi, welcome back to Analysis of Algorithms, Part 6, Number of Spanning Tree. In this class, we're going to provide a bit more complicated example. In the last two previous classes, we provided a four-node graph. Now here we are providing six-node ring or graph, and we're trying to find number of spanning trees using Kirchhoff matrix tree theorem. Each spanning tree is formed by removing one edge from the cycle, and M stands for a minor matrix. More precisely, we expand a determinant using cofactors, and we remove one row, one column. The remaining smaller matrix is called minor matrix, and it is determined as written Mij. So M11, M12, and etc. So M11 means determined after deleting row 1, column 1. M12 determined after deleting row 1, column 2, for example. That's column 1, column 2, and so on and so forth. So minor, we said that we can signify it by M sub ij, and cofactor is C sub ij minus ij, that's the cell, multiplied by the output of the minor matrix. So that's determinant of the smaller matrix, that's minor, and Cij signed version used in the expansion. So determinant equals 2 M11, which is already included the sign changes, plus M12. So here we have an example how to find 2 by 2 matrix. For example, if you have A, B, C, D, A matrix. So determinant equals A times D minus C times B. So that's the determinant. That is the determinant. So in this case, if we have 2 by 2 minus 1, minus 1 minus 2, 2 multiplied by 2, minus 1 multiplied by minus 1. So 2 multiplied by 2 minus 1 multiplied by minus 1. So plus 4 minus 1, that's the 3. So the determinant A is 3. Now, likewise, determinant of 3 matrix. For 3 matrix, we expand using smaller 2 by 2 determinant, and it becomes a combination of smaller parts. So if determinant is 0, the matrix collapse space, we call it, no inverse exists, and system is dependent. If determinant is not equal 0, matrix is valid, inverse exists, system has independent structure. So that's what we wanted to just define so far. 2 by 2 determinant area scaling, 3 by 3 determinant volume scaling. So this is the example that we have. We have 1 is connected to 2 and to 6, 2 connected to 3 and 1, 6 connected to 5 and 1, and 5 connected to 4 and 6, and 4 connected to 3 and 5. So each node, it's connected to 2 other nodes, okay? So we have given a cycle 1, 2, 3, 4, 5, 6, 1. That is 1, 2, 3, 4, 5, 6, and 1. That's the cycle. And n, the number of nodes are 6, and each vertex has degree of 2, which we said, for example, 1 connected to 1 to 2 and 1 to 6, and 4 connected to 4, 5 and 3, 5 connected to 6 and 4, 3 connected to 4 and 2, 2 connected to 1 and 3, so on and so forth. So here we proceed mathematics. So 2, it has 2 connections, Row 1, first node has two connection. Row 2, second node has two connection. Row 3, third node, third vertex has three connection, and so on and so forth. And you can see this diagonal means that every node has two connections. That is the matrix D, which is the degree matrix is formed. We'll do the adjacent. Node 1 is not connected to itself, but it's connected to 2 and 6. So that's 2 and 6, node 6. And node 2, it's connected to 1 and to 3. Go back. Node 2 connected to 1 and 3. So that is the node 2, but it's not connected to the rest. And node 3, that node is not connected to itself, but it's connected to 2 and connected to 4. Let's see. Node 3 connected to 4 and to 2. So we're putting for the 2 is 1 and for 4 is 1. So on and so forth. This one also adjacent connection. 1 is to 2 and 6. 2 is to 1 and 3. 3 is to 2 and 4. And 4 is connected to 3 and 5. Let's see 4. That is 4 connected to 5 and connected to 3. So forth. We did it. Now, Laplace L equals D minus A. D is degree matrix minus A adjacent. So here element-wise, 2 to this 2 minus 0, 2, and 0 minus 1 is minus 1. So that is the D minus A matrix will get L matrix. So we have L matrix came from this D element-wise minus A. So D minus A, you will get L matrix. And we did it L matrix. So that's L matrix. Here for the Kirchhoff, we try to reduce one row and one column. So reduce the row 6. This row will be deleted, and this row will be deleted. So we will have this matrix. That is 2 minus 1, 0, 0, 0, and minus 1, 2, minus 1, 0, 0. So we call it Laplacian reduced. That's Laplacian reduced by one row and one column. So that's Laplacian reduced by one row, one column. So we reduce this row and we reduce this column. Now, compute determinant for reduced Laplace. So it's for the first row is this one, 2 minus 1, 0, 0, 0. So 2 minus 1, 0, 0. And we will get the law 2m11 minus the sign contribution minus 1m12. So we will get m1 and m12 next. So to compute m1, we have this matrix. This matrix means what? We have this L, which we reduced the first row and first column. So first row, take it out, and first column, take it out. So these two rows are taken out. Now we have only this left. That's our matrix, which is 4 by 4. So 4 by 4. Now our matrix 4 by 4. Now expand M1 along R1. So expand M1 along R1. So we have 2A plus 1B, and let's get M11. So how to get M11? We'll take row 1, 2 minus 1, 0, 0. So now we're again compute A. To do A, we will get determinant. We will remove row 1 and column 1. Here again, row 1 is reduced and column 1 is reduced. So now we will have this one. So 2 minus 1, 0, minus 1, 2, minus 1, 0, minus 1, 2. That is what we have. That is A. So do the expand A along row 1. So this is the first term. If we take the first term, we will ignore this part and ignore this part. Not remove, just ignore. So we will do the calculation for this one. So 2 multiplied by 2 and minus 1 multiplied by minus 1. So I'll try to do it one more time so that you don't forget it. Here, remove this. Sorry. Remove this and remove this. So 2 is this 2 multiplied by this part. Okay, so 2 multiplied by 2 and minus 1 multiplied by minus 1 multiplied by 2. Then, and here for this one, minus 1, the second term, it will be what? This one is ignored and this one is ignored. So we will have minus 1, minus 1, 0, 2. So minus 1, minus 1, 0, 2 multiplied by the minus 1. That's for the term itself, multiplied by this one. So just to show you again how we have done it. So that's for first term, it's here. Sorry. For the first term, it's here. Okay, for the first term, this one. So we'll take this 4. It's 4. For the second term, this one is neglected. For minus 1, this one. This row is neglected. And this column is neglected in the middle. So, and then minus for the negative contribution multiplied by, it is that this minus 1 represent this minus 1 multiplied by the matrix minus 1, minus 1, 0, 2. So here for the first two, that's the result. 2 multiplied by 2, 4, minus 1 multiplied by minus 1, plus 1. So this 2 multiplied by 2, minus 1 multiplied by minus 1. So it's 3. 3 multiplied by 2, this 2, which is this 2, first term. So it's 6. For the second matrix, minus 1. Okay, so minus 1 multiplied by 2 and 0 multiplied by minus 1. We will get it, and the result is minus 2, and then multiplied by minus 1, the term, and negative. So we will get minus 2. And to get A, this 6 minus 2, we will get 4A. That is done to get computing A, which is 4. Now, to get subset B, how we get subset B, we will go to the earlier matrix. How we found this one, just go back to here, So how we got this one, we will get it by removing the first row and removing the second column. So removing the first row, 2 minus 1, 0, 0, and removing the second column. So then we would have what? We would have minus 1, minus 1, 0, and we would have 0, 2, minus 1. So minus 1, minus 1, 0, and we have 0, 2, minus 1, and we have 0, minus 1, 2. So let's see, we should have minus 1, minus 1, 0, first one. Yes, for the B, minus 1. So just do it again so that you don't forget it. I just do it again how I got, let me get the pen to cross it. So how we can do the B, how to compute B, or how B was found. Well, B was found by removing, B was found by removing this row and this column. So what's left is minus 1, minus 1, 0, 0, 2, minus 1, and 0, minus 1, 2. 0, minus 1, 2. So 0, minus 1, minus 1, 0. That's the first row. 0, 2, minus 1. That's second row. And the third row, 0, minus 1, minus 2. So this one is ignored. This one is ignored. And that's how we got the B. Now, doing the B, the first term multiplied by this part. If this one is ignored and this one is ignored, 2 multiplied by 2, minus 1 multiplied by minus 1. And so what we get, multiplied by minus 1. So 2 multiplied by 2, 4, minus 1 multiplied by minus 1, plus 4 minus 1, minus 3, 4 minus 1, minus 3, 4 minus 1, 3, multiplied by minus 1, that is minus 3. And then we have 2a plus b. b is 5 in the equation. 2a plus b to get m11. 2a plus b. a was 4. 2 multiplied by 4 plus b is 5. So let's do it. 2 multiplied by 4, 8, plus minus 3 that we have. Minus 3, we have b. Sorry, b is minus 3. 8 minus 3 is 5. So we got M11, 5. Now we do compute M12. How to get M12? Remove row 1, column 2. Remove row 1, column 2. We go to our here, remove row 1 and column 2. We should get minus 1, minus 1, 0, 0. We remove this one and we remove this one. We should get minus 1, minus 1, 0, 0, 0, 2, minus 1, 0, minus 1, 0. Let's do it. So minus 1, minus 1, 0, 0, 0, 2, minus 1, 0. That's what we get it. Likewise, we'll do the to find M12, we will remove M12. We will have remove this one and this one. Then we have 2 minus 1, 0, and minus 1, 2, minus 1, and 0, minus 1, 2. So that's what we have. We multiplied by minus 1. And because we already computed this one in the earlier, if you just check to earlier, that we have 4 for the A is this one. We already did this one. That is 4. That was done. So that is the matrix multiplication for it. We did this part that gives us 4, and M12 is 4. M12 is multiplied by minus 1, this minus 1. So it's minus 4. Now, let us do it. Determinant is 2 multiplied by M11 plus M12. M12 is minus 4, just found it. And M11 is 5 multiplied by 2. So 10 minus 4 is 6. So number of spanning tree is 6 for this example. And that's the results of 6 spanning trees. So that is the explanation of how we can get a 6-node graph or 6-node shape. If you have any question, please check this links for further information or drop me an email. Thank you very much and stay tuned.